determine the number of solutions of a system of linear equations? Think about this question during the lesson. Deanna drew the 3 pairs of lines below. Each pair represents a system of linear equations. A system of linear equations is formed by 2 or more linear equations that use the same variables. How can you use the graphs to determine the number of solutions of each system?
A solution of a system of linear equations is any ordered pair that makes all equations in the system true. The equations of the first linear system have different slopes. The lines on this graph intersect at only one point. The system has one solution, the ordered pair, 1, 5, or x equals 1 and y equals 5. The equations of the second linear system have the same slopes and different y-intercepts. The lines do not intersect and never will. They are parallel lines, so this system has no solution.
The equations of the third linear system have the same slopes and the same y-intercepts. The lines intersect at every point. They're equivalent equations, so they are the same line. This system has infinitely many solutions. Comparing the equations in a linear system can show you whether the system has 0, 1, or infinitely many solutions. When equations in a linear system have different slopes, the system has one solution. When a linear system describes parallel lines, the system has no solution. When a linear system describes the same line, the system has infinitely many solutions. How do the points of intersection of the graphed lines relate to the solutions of the systems of linear equations? The coordinates of the point or points of intersection x, y are the solutions to the system of linear equations. The first graph has one solution, the second graph has no solutions, and the third graph has an infinite number of solutions.
How many solutions does this system of equations have? Explain.
The system of equations has blank solution. So if we look at our equation, the slope here is different. This one is 1, this one is 2. So we would put here that it has one solution. Because when they have different slopes, that means they have one solution. The equations have different slopes, so the lines intersect at only one point. So here would be, let's try that again, have different slopes. Okay.
Which of these ordered pairs, 0, 4, 6, 7, or 9, 8, is a solution to the system of equations? Y equals 1/3 times x plus 5. Y equals 1/2 times x plus 4.
Substitute each ordered pair into both equations and evaluate. So you take the first ordered pair and you put it in here. Remember, this is x, this is y. So x goes here, y goes there, and then you solve. When you solve it for each one, you do the same thing. And you see that the ordered pair that satisfies both linear equations simultaneously is a solution to the system. The solution is 6, 7 because the ordered pair satisfies both equations. So when you see that equal sign with the line drawn through, that means not equal to. So in this ordered pair, this equation is not equal, but this one is. In this one, both are equal. And then the last one, this is not equal and this is equal. So this is the only one that satisfies both solutions.
An aquarium charges different ticket prices for adults and children. Did Aurora, Dion, or Nina estimate the ticket costs exactly?
All right, so we have the price estimates. You have the students, the price of the tickets. And then you have the graph here that shows the equation. So we're going to substitute the estimated prices into both equations. So for Aurora, we're going to take her $9 for adults, $7.75 for kids, put it into both of the equations for each line, and see which is the solution. So in this case, neither is a solution, neither point. So Aurora's does not work. Let's look at Dion. We put in his numbers, and then for Dion, both do not provide a solution as well, so that's no. Then we look at Nina, and Nina's ordered pairs are equal for both equations. So Nina estimated the cost exactly. The ticket prices are $9.50 for adults and $7.50 for children.
Identify the ordered pair that is a solution to the system of equations. Part A, 2, 16, or 1/2, 7. Y equals 6 times x plus 4. Y equals 4 times x plus 5.
So we're going to substitute the ordered pairs into the equation. So I'm taking my first one and putting it in. I'm going to take the second equation, do the same thing. 16 equals 4 times 2 plus 5. Okay, so now I'm going to solve. So this would be 12 plus 4 equals 16. And then 12 plus 4 is also 16. So that's good. Then we have 16 is equal to 4 times 2 is 8 plus 5. 8 plus 5 is 13. So that is not equal. Then we're going to look at, let's do purple. Then we're going to look at the second ordered pairs and substitute them into the same two equations. So we have 7 is equal to 6 times half plus 4. Then we have 7 equals 6 times, supposed to be a 4. Okay, 4 times half plus 5. So then we solve. So 6 times 1/2 is 3. So we have 3 plus 4, and then 7 is equal to 7. And then we have 7 is equal to 4 times half, which is 2 plus 5. And then 7 is equal to 2 plus 5 is equal to 7. So the second ordered pair is the solution to the system of equations because both satisfy the equation. Both solutions satisfy both equations. Identify the ordered pair that is a solution to the system of equations. So we do the same thing we did with the last one. We're going to take the first equation in the orange. I'll do that one. So I'm going to take my first ordered pairs. 1.25 is equal to 0.25 times 1 is plus 1. And then the second is 1.25 equals negative 0.75 times 1 plus 2. Okay, so 1.25, my handwriting is not the best on here. Okay, 0.25 times 1 is still 0.25 plus 1. And then 0.25 plus 1 is 1. 1.25. Then we go to this equation, and then we have 1.25 is equal to -0.2, and then 1.25 is equal to 1.25. So this ordered pair satisfies both equations. So now let's take a look at the second ordered pair. So I'm going to delete everything. All right, so now we have 0.875 equals 0.25 times 1.5 plus 1, and then we have 0.875 equals negative 0.75 times 1.5 plus 2. Now we solve 0.25 plus 1.5 is 1.75. So 1.75 plus 1. And then we add that, that'll be 0.875 is equal to 2.75. Then the next one, excuse me, we have negative 0.75 times 1.5 equals negative 1.25. 875 equals negative 1.125 plus 2, which would be 0.875 equals 1.125, and those do not satisfy our solution. So the second order pair would not work, and the first one would be the solution to the system of equations.